In today's lesson, we are going to talk about limits and continuity. To start the lesson, we are going to start with an example. You have a driver that parks her car in a parking lot. The fee is $3 for the first 20 minutes or less, and an additional $2 for each 20 minutes or part thereof. We are supposed to represent the function that models this situation. Let's define C to be the cost function, which is based on the time. Then our cost function is going to return $3 if the time is less than or equal to 20 minutes. Then when the time goes additional 20 minutes, meaning between 20 and 40 minutes, then the cost is $2 extra, so it's going to be 3 plus 2, which is $5. And the time is between, let's say, 60 minutes and 40 minutes, then it's going to be $2 plus $5, which is $7. So this is our function for the first hour. The next question says, how much will she owe the lot after 1 hour? You can see that after 1 hour, she owes the lot $7. If we go ahead and plot the function representing the example which we did previously, we are going to get a graph which looks like this graph. From 0 to 20 minutes, the cost is always $3, which is represented here. From 20 to 40 minutes, the cost is $5. And when it's between 40 and 60, the cost is $7. This is what we call a piecewise function, which is made up of pieces as is shown on the graph. There is another name for this function which we call a step function. Notice that the function is continuous because, as we said before, if we wanted to plot this graph, we should raise our pen to go from one part to another one. Or, as we said before, because the limits at points 20 minutes and 40 minutes, the left and right hand side limits are not equal, the function is discontinuous. Now we are going to talk about the limits and all the properties which we can use when evaluating the limits of functions. The first property of limit is that the limit of a constant is equal to the constant. This means that the limit of x goes to a of a constant c is equal to c. The reason is that this function does not have any variable x. So when x goes to a, the function doesn't change and it's also equal to c. The next property is the limit of the function which is just x. When x goes to a, the limit of x becomes a. The next property is the limit of the sum of the two functions. The property says the limit of the sum of the two functions is the sum of the limit of each individual function, meaning that the limit of f of x plus g of x is the same as limit of f of x when x goes to a and limit of g of x when x goes to a. Give you one example. If we have to find the limit of x goes to 1 of, let's say, x plus 1. This is the same as limit of x goes to 1 of x plus limit of x goes to 1 of 1. This one is going to give you 1, this one is going to give you 1, so the answer is 2. Which is the same as here. If you substitute x equal to 1, 1 plus 1 is going to give you 2. The next property says the limit of the difference of two functions is the difference of the limit of individual functions, which is exactly the same as the previous property, the limit of the sum of the two functions. The next property says that if you have a function of the form a constant c times a function, to find the limit of the combined when x goes to a is the same as saying constant times the limit of the function when x goes to a, which somehow we are using the first property, that the limit of a constant is the constant. And this way we can find the limit of a compound function. For instance, the limit of 2x when x goes to, let's say, 1 is the same as 2 times the limit of x goes to 1 of x, which is 2 times 1, which is equal to 2. The next property says the limit of the product of two functions f of x and g of x is the same as the limit of the first function f of x times the limit of the second function g of x. This is the product rule of limits. Give you example, for instance, limit of x squared when x goes to 2 is the same as limit of x goes to 2 of x times the limit of x goes to 2 of x. The first limit here gives you 2. The second one gives you 2, so the answer is 4. And if you look at the original one here, you substitute x to 2, you get 2 squared, which is going to give you 4. The next property, which is the limit of quotient. If you have a fraction, two functions, then the limit of f of x over g of x is the same as the limit of the numerator divided by the limit of the denominator. Of course, since you cannot divide any number by 0, the condition is that the limit of the denominator, which is limit of g of x, cannot be equal to 0. The next property says that the limit of a function to an exponent, like this one, limit of x goes to a of f of x exponent n, is the same as limit of f of x when x goes to n and the result to exponent n. This is the same as this example. For instance, if I say limit of x exponent 2 of x going to 2 is the same as limit of x go to 2 exponent 2. This one is going to give me 2 exponent 2 is going to give me 4. The last property is the limit of a root function. If you are supposed to find the limit of x going to 2 of root n of f of x is the same as root n of limit of f of x, provided that under the square root exists. meaning limit of x goes to a of f of x exists. This was just an overview of all the properties of the limits. Now we are going to start doing some examples here. The first example says evaluate each limit if it exists and indicate the limit properties used. The first example is a, which is limit of x goes to -1 of 5. Since 5 is a constant, the limit is always the constant, so the limit is 5. B. Find the limit when x goes to 2 of 3x4 minus 5x. This is the same as limit of 3x4 minus limit of 5x. Now limit of 3x4 is the same as 3 limit of x4, x goes to 2, minus 5 limit of x, x goes to 2. Now I can write the first limit as 3 limit of x when x goes to 2 exponent 4 minus, but limit of x when x goes to 2 is just 2, so it's 5 times 2, which is 10. Now limit of x, x goes to 2 is 2, so we get 2 times 2 exponent 4 minus 10. 2 exponent 4 is 16, so it's 48 minus 10, which becomes 38. Now you can see the step-by-step process that was involved in simplifying this limit. In general, you do not follow all these steps like this one. You just use the property and then you evaluate the function when the variable is going toward the limit. The next example is limit of 2x plus 5 when x goes to -3. Using the property of the root n of a function, this is the same as square root of limit of 2x plus 5 when x goes to -3, which is the square root of the limit of 2x plus 5 when x goes to -3 is 2 times -3 plus 5, which is -1. -6 plus 1 is -1, and the square root of negative numbers do not exist, so the limit of c is undefined. The next one, it says find the limit of x goes to -1 of x squared minus 4 divided by x squared plus 4. To do this one, when x goes to -1, the denominator becomes -1 squared plus 3, which is 1 plus 3, which is 4. So the fraction is defined, so we are going to let x to be equal to -1. So this becomes -1 squared is 1 minus 4 divided by -1 squared is 1 plus 3, which is 1 minus 4 is -3. 1 plus 3 is 4, so the answer is -3 over 4. The next one is e, which is limit of x goes to 0 of x minus 3 times 5x squared plus 5. The function is not under the square root or no denominator, so we just simply substitute x equal to 0 in the equation, we get 0 minus 3 is going to give us negative 3, and 5 times 0 squared is 0 plus 2 is 2, times 2 is negative 6. The last one is 5x over x minus 2 when x goes to 2. Since x minus 2 is in the denominator and x goes to 2, x minus 2 is going to become 0. So the denominator is 0, and there is no way we can simplify this fraction. We can just say that the limit does not exist, or it's undefined. So the answer to part F is undefined. The next question says, examine the graph, which is given here. State the domain of the function. As you can see, the function is defined for all x values, even for x equal to 1 here, although we have 2 holes here, but this one is defined here. So we say that the domain is x such that x is a member of real numbers. Now we have to evaluate each of the following limits. The first limit is the limit of the function when x goes to 1 plus. When x goes to 1 plus, this means that you are going toward this to the left. This means that the graph that we have to look for is this graph. When we get close to 1 but not equal to 1, the limit is here. So we say the limit is 2. The next one, it says limit of the function when x goes to 1 minus. When x goes to 1 minus, we are moving this way. So this is the graph we are to look for. When we get to 1 minus, meaning that x is 1 but not exactly 1, less than 1. So this is the limit. The limit is going to be about 0.5. Now the question is that what is the limit of the function when x goes to 1? Since when x goes to 1, the left and right limits they are not equal. This is 0.5, this is 2. We say that this is undefined. What is the value of the function at 1? The value of the function at 1 is here, which is negative 2. You can also notice that without even having the graph, just having the equation, we can find the limit. For instance, for the part A, it says limit of x going toward 1 plus. 1 plus means that x is a little bit greater than 1. This means that we have to use this because x is greater than 1. Now, if we evaluate the function at this point at x equal to 1, we get negative 1 plus 3 is 2, which is here. The next one, here, when x goes to 1 minus, this means I have to use this function because x is less than 1. If we set x to 1, 0.5 times 1 squared is 0.5, which is here. The next question is saying, is the function continuous or discontinuous at x equal to 1? The answer is no, it's discontinuous because the left and right hand side limits at x equal to 1, they are not equal. One is 2, the other one is 0.5. The next question is to examine the given graph and answer the following questions. First, what is the domain of the function? we can see that the function is valid or defined for x values except when x is equal to 4, because this is a vertical asymptote. So we say that the domain is equal to x such that x in R and x is not equal to 4. The next question is to evaluate each of the following limits. The first one is part A, which we have to find the limit of x plus 1 over x minus 4 when x goes to 4 from the right. From the right means this way. So we have to look at the graph here, and you can see when x goes to 4 from the right, the function goes to plus infinity. When x goes to 4 from left, meaning this way, this means that the function goes to minus infinity. When x goes to 4, the limit of the function does not exist because the left and right limits are not equal. So we say undefined. And the last one, we have to find the value of the function of 4, and since again, either from the graph we can see that the function is not defined at 4 or the limits are not equal, so undefined. The last part of the question says, is the function continuous or discontinuous? The function is discontinuous at x equal to 4 because the limits do not exist on the left and right. The next question says, look at the graph given here and answer the following questions. The first one, what is the domain of the function? The domain is x such that x in R, and since the function is defined for every value of x, this is the domain, all the real numbers. The next question says evaluate each of the following limits. First, limit of 0 from left of 2x squared over x squared plus 1. If we look at this function and go from left, we can see the limit at x equal to 0 is 0. If we go from right, then the limit again is 0 when x gets close to 0. Then the limit when x goes to 0, since the left and right limits are the same, it becomes 0, and the function at 0 is 0. The next part of the question says, is the function continuous or discontinuous at x equal to 0? The function is continuous. First, from the graph, you can see that there is no discontinuity at x equal to 0. And also because left and right limits are the same, equal to 0. So the function is continuous at x equal to 0. The next question, we have to evaluate each of the following limits if they exist. The first one is limit of x goes to 1 of x squared minus 6x plus 5 over x squared minus 3x plus 2. The function is a rational function. If we evaluate the denominator, we get 1 squared minus 3 plus 2, it becomes 0. And number divided by 0 does not exist. So we have to try to see if we can simplify this one. I can write this one as limit of x goes to 1 of the numerator. I can factor this one out. Since the leading coefficient is 1, I can use sum and product. I'm looking for two numbers that the product is 5 and the sum is negative 6. Those two numbers are negative 1 and negative 5. So I can write this one as x minus 1 times x minus 5. and the denominator, the leading coefficient is 1, so I can use sum and product method. Two numbers that the product is 2 and the sum is -3. Those two numbers are -1 and -2. This I can simplify x minus 1, so I get limit of x goes to 1 of x minus 5 over x minus 2, which is 1 minus 5 is minus 4, 1 minus 2 is minus 1, which is 4. So the limit of a is 4. The next one is the limit when x goes to 0 of square root of 4 plus x minus 2 over x. Again, this is a rational function. When x goes to 0, the denominator becomes 0. So I should try to simplify this one. I can write this one as a limit of x goes to 0. I try to rationalize this rational function. So I write this one as 4 plus x minus 2 times square root of 4 plus x plus 2. I multiply by the same factor. Now, if you look at the numerator, you can see that this is the difference of squares. So I can write as limit of x goes to 0. Square root of 4 plus x minus 2 times square root of 4 plus x plus 2 is square root of 4 plus x squared, which is 4 plus x, minus square of 2, which is 4, divided by x, divided by square root of 4 plus x plus 2. 4 cancels with 4, x cancels with x. So when x goes to 0, this becomes 1 over square root of 4 plus 0 is square root of 4, which is 2 plus 2, which becomes 1 over 4. The next one is the limit of x goes to -3 of 1 plus x squared minus 4 over x plus 3. If you substitute -3 for the denominator, it becomes 0, so we have to be able to simplify it. To simplify, I look at the numerator, and this is the difference of squares, so I can write this one as limit of x goes to -3 of a squared minus b squared is a plus b times a minus b. So I can write a 1 plus x, square root of 4 is 2, so it's plus 2 times 1 plus x minus 2 divided by x plus 3. Now 1 plus 2 is 3 plus x, so I get limit of x to -3 of 1 x plus 3 times x minus 1 over x plus 3. X plus 3 goes with x plus 3, so I get limit of x goes to -3 of x minus 1. And x minus 1, if I find the limit, this becomes -3 minus 1, which is minus 4. The next example is a word problem which says that you have a Tim Horton restaurant that determines the demand for a new flavor of coffee is modeled by this function, where D is the number of cups of coffee which is sold, and P is the price of single cup of coffee. If the price is between 0 and 4 inclusively, then the number of coffee sold is 16 over p squared, and if the price is greater than 4, the number of coffee sold is 0. Now we have to find the following limits. The first limit is when the price goes from the left to $4. Since the price goes from the left to $4, this means that I have to use this part of the equation. This means that I have to evaluate 16 divided by p squared. P is 4, so 16 divided by 4 squared is going to give me 1. When the price of the coffee goes from to 4 but from right, I have to use this function. This means that the number of coffees sold is going to be equal to 0. Then it says, what is the limit when p goes to 4? Since the left and right side limits are not equal, then I can say that it does not exist, so undefined. Now interpret the meaning of these limits. It means that as long as the price is less than $4, I'm going to sell one coffee. If the price of the coffee goes over $4, then I'm not going to sell any coffee. And the function is discontinuous at p equal to 4.